Alright, so this is lab 2, projectile motion. So basically in this lab, we had a ball and we threw it up in the air. And as you can see in the background, there's a meter stick. And the meter stick was basically just for scale, just to kind of like be able to scale it and be able to see the actual distance it traveled. During this lab, we used glow script, and it was related to air resistance, as you can see. All right, so the procedure consisted of throwing a ball up in the air and tracking its movement. There was no added force besides gravity, and it was compared to a meter stick and recorded on an iPhone. Afterwards, the video was put into Tracker. Tracker is a software that can record data associated with motion in a video. The center of the object was recorded at each frame on a 0.01 per 1 second scale. It flew in the negative X direction, and the tracker then plotted a graph and a set of data. Here's the data from the tracker. As you can see on the left, there's a line graph showing the relationship between time and the X direction, and then the one on the bottom is the relationship between the Y component and time. And on the right, you can just see all the data. The left column is time, right column is X in meters, and the rightmost column is Y in meters. All right, and then after that, we were put it into glow script, and glow script basically was able to help us do a predicted movement of the ball, which we will later compare with the actual movement. So for glow script, we used two different models. The first one we used was just basically everything was constant and we had no drag force. The second one, there was a slight drag force, and you could see through the arrows showing the direction of the motion. So the top graph is with no drag force and the bottom one is with drag force. Here's the glow script codes, as you can see right here. And then here's a graph comparing the two. The light blue is going to be the actual position, and then the dark blue is the predicted from glow script. So some concept questions. Terminal velocity occurs when the net force on an object becomes zero. In the gravity only model, the object continuously accelerates downwards, no terminal velocity is reached. In the gravity plus drag model, drag force increases with speed. Eventually, drag force equals gravitational force. Net force becomes zero. Velocity becomes constant, terminal velocity. If the object is thrown straight up with the same initial speed without drag, time goes up equals time coming down. Total time is symmetric. With drag, air resistance opposes motion both up and down. Object slows down faster going up, falls more slowly coming down. Total time is longer than the original motion. So in conclusion, the gravity-only model predicts basic projectile motion but is not fully accurate. The experimental data shows deviations due to air resistance. Adding drag improves the model and better matches real motion. Air resistance plays a significant role in real-world projectile motion. Thank you.